Hi, I am Sri Vignesh from CSC 512. In this demo, I'll show Cockroach DB special feature on a special NYC dataset and briefly explain about how its distributed architecture works. So as we see here, I have started a single node cluster with Insecure, the web UI at the local host. Even on one node, the Cockroach DB behaves like a distributed SQL system. So let's get into the creating database tables. So yeah, this is the code for creating the database tables. In the SQL shell, I am creating a database NYC data, two tables, bird sightings and bookstores, and inserting a few point geometrics, longitude and latitude. So let's get into the first query, which is proximity. Yeah. STD within finds bird sightings within about 2 kilometers of each bookstore. This is a classic proximity search pattern used in local recommendations and logistics. So let's get into the second query, which is distances. Here, as we see, the STD distance returns pairwise distances in degrees here. Sorting shows which bookstore is closest to which bird sighting. And the fourth query is the nearest neighbors. This query gets the nearest bird species for each bookstore. It's a practical pattern for closest POI lookups. And the fifth query is also known as buffers and intersects. Here I used ST buffer and I draw a 1.5 kilometer zones around bookstores. And ST intersects checks with sightings fall aside. This is useful for coverage and service area analysis. So finally, distributed architecture. Under the hood, Cockroach DB automatically partitions data into ranges, replicates them via raft, and executes queries in parallel across ranges or nodes while keeping serializable isolation. And I'll run explain analyze to show the physical plan distributed operators. So as we get into the wrap-up, here are the key takeaways. Spatial SQL is expressive for proximity, distance, and zones. Cockroach DB gives distributed scale and strong correctness. And I'll include the private video link in the screenshots in my second page PDF. So yeah, thank you.